So back to this problem, right? So you could write this as two separate inequalities. The one on the left would be negative 3 is less than or equal to x over 2 plus 1. And then the one on the right, I'm not going to do this, by the way, because I think it's better if we can get the other way. X over 2 plus 1 is also less than or equal to 5. So you could just solve these two. And since you love solving inequalities, yes, I'm being sarcastic, but you could have as much fun solving these as much as you want twice, okay? But here's the thing. If you did this, you'd notice, first thing, that you'd subtract 1 from both sides up here, like this, to zero out your 1s, right? But you would end up doing the same thing to this one, right? Subtract 1 from both sides, and then you'd have your principle of equality taken care of. What I can do is I can apply that to the current inequality by saying, look, I subtract 1 right here because I'm trying to isolate the x's still. There's my, remember the lines like this? But now instead of doing it to 2 sides, I got to do it to 3. Oh, dang it. There we go. Okay, so I can apply these principles of equality to 3 parts of an inequality like this, okay? So what am I left with? Negative 3 minus 1 is negative 4. Of course, that's zeroed out. So I do drop the x over 2. And then 5 minus 1 is 4. So the inequalities don't change because we didn't have a negative coefficient. And now, to solve this inequality, I just want the x in the end. And I don't want to divide by 2, so I'm going to multiply that by 2. So multiply everywhere by 2, all parts by 2. So 2 times negative 4, that's negative 8. And then 4 times 2, there's positive 8. Okay, so x, negative 8 is less than or equal to x, which is less than or equal to 8. Okay, I guess, oh, they did want this in inequality notation, so actually that's as far as we need to go on. Oh, as far as we need to go on this one.